Hello and welcome back to Ezigrade. In this example we're going to take the plane surface we designed in the example 1 and we're going to show how we can do a constrained grade design. So if you open up the example 1 which we'd previously run, so it's in the Documents Ezigrade 2 directory. And before we go any further, what we're going to do, we're going to save this job as a new job name. That way we can keep our old plane design and we can go back and compare designs at a later date. So we went to File, Save As, and we're now running example 2, which is a completely new job, but it's taken up all the parameters of the first job. So we look on the left here, in example 1 we designed as a plane. Now we want to design it as a constrained grade of best fit. So what this means is that the minimum and maximum grades can vary within limits, and we can set those limits so that we can control how the water runs. So in this example the water runs from the top of the job to the bottom. Now across the job we don't care, so we're going to leave the X values unticked, and we're going to constrain the Y values. So the minimum Y value we're going to say is 0.08. These numbers are completely you can set these numbers to whatever you want to set the water flow. We're going to use 0.08 and 0.5. Once that's done, click on grading again. Now here, as mentioned before, we've got two types of grading. We've got grid-based and triangle-based. Grid's based on a grid, which is a bit of an approximation, and we've got triangle-based, which uses the exact triangles that make up the job. We'll have a look at both values and see how they compare. So we'll click on grid-based and use a grid size of 10 meters, and click OK, and that's given us a value. And as a comparison, we'll have a look at the cut value. For this design, the cut volume is minus 893 cubic meters. I think if you go back and look at example 1, the plane solution was minus 3,800, so it's significantly less. Click OK, and we'll have a look at the automatically shows up surface 2, which is our design. Now we'll run this again as a triangle base, see what that value gives us. It takes a little bit longer because there's more calculations it does. It's given a value of minus 754, so it's probably 10% better than using a grid approximation. So we'll go with a triangle based solution. Now also, if you run the grading again, grading triangle based, you see there's a value here for smoothing. What that does, it'll give us a smooth type design rather than the jagged one we've just looked at that does drain. Now what it does, it uses a thing called moving least squares, and we give it two parameters. We've got a smoothing distance and a sampling distance. Now the sampling distance is from each point in the job it looks at. It compares all the points within that distance, and the smoothing distance, which is less, it gives those points in that range more weight. So as long as the smoothing's less than the sampling, we're fine. Probably keep them about 2/3. It's a good rule of thumb, but you can play with those values. Now click on post smoothing, click OK, and the cut volume's gone up to minus 1700, which is half the plane solution and double the non-smooth one. But if you look at the results, a lot more acceptable. If you want to look at cut fills, this is the same cut fill values as we used in the plane, and if you look at now, there's hardly any cut and fill greater than 6 centimeters, so it's obviously a better solution. Okay, thank you for looking at this second job, and we'll see you on the next one.